We'll just try it this way. All right. So we drew the vectors listed in the problem. Then we're going to draw our resultant. From the tail of the first to the head of the last. Tail of the first to the head of the last. A lot of times students on a problem like this say, oh, I see right triangles. I see them. How many right triangles do you see in this picture? There are two cute little right triangles, right? There's one right here. There's one right here. Here's the problem with that plan. I don't have any idea where on that 3.1 this intersects. You with me there? I can't tell. So instead of trying to be fancy like that, I mean, I could do that math. I could figure it out, but that sounds like a lot of work. Okay? Instead of doing that, step 3 is that I want you to find a right triangle that one right triangle, I'm going to change that from an A to a 1, that uses the resultant as its hypotenuse. There are two good choices in this problem. You can either go down and over, or you can go over and down. It does not matter. Okay? If you're feeling brave mathematically, then I want you to try the opposite of the one I'm going to do, just so that we can see if it works. Okay? But if you're like, I don't know this stuff very well at all, I really want to follow you step by step, Miss Carbling, then just follow me. That's totally fine too. Okay? The triangle I'm going to do is going to go down, and then it's going to go over. Okay? So if you're feeling mathematically brave today, then why don't you try to go over and down, and we'll see if we can get them to work the same way, because it should be fine. Okay? So just to make sure you can see this triangle, because it's hard sometimes to see them, there's one leg, there's one leg, and this is my hypotenuse. Okay? There's my right angle. Everybody good? Yeah? Okay. Now I need to figure out what the lengths of the legs of my right triangle are. So I'm going to put that as step 4. Determine the lengths of the legs of the right triangle. How long is this leg? 3.1. It's got to be, right? What else would it be? I don't know. It's got to be 3.1 because that's all we went down, right? 3.1 kilometers. This one's a little bit less intuitive, but it's probably pretty easy to see if you look hard. What's the length of this long leg down here? 10.4? Where do you get your 10.4 from? You got it. Life is okay? Step 5, Pythagorean theorem. Woo, woo, woo. So we're going to use the Pythagorean theorem to find the length of the resultant. Okay. So let's do that. So we're going to say a squared plus b squared equals c squared. C squared is my resultant. So I've got 10.4 kilometers squared. I've got 3.1 kilometers squared, and that's going to equal the resultant, my displacement. So right now I've got c squared. How do I undo the squared? Square root. So I'm going to take the square root of that sum. Go ahead and do that. Tell me what you get. Everybody should do it. Everybody's using their calculator. Maybe you've already done it, but if you haven't, type it in right now. If you have, check with your table mate and see if they agree with you. One thing to note about this length, the length of the hypotenuse, is that it has to be longer than either of the two legs, right? We know that. You proved that in geometry. It must be true. It must be true. All right, let's see here. Oh, Madeline, did you guys get an answer? 10.85, she says. Do you guys agree with her? 10.85 what? Kilometers. Are we done? No! What else do you want to know, Sam? Direction. We want to know the direction, right? So then we're going to get clever and we have to figure out what angle we're going to use. Remember, we're going to choose the angle from the starting point. The angle in the triangle that includes the starting point. So step 6, identify the angle in your triangle that includes the starting point. And step 7 is to use trig functions to find the angle. I'm going to add both of those together. So there's my angle right here, my angle theta. Again, if I've got my brave mathematicians, they're going to use this triangle. They're going to use this angle. And you're not going to get scared. It'll be fine. Just trust me. Okay. Do I have some brave mathematicians working in here? I hope so. Maybe 1 or 2 of you. All right. So now, in terms of choosing which trig function to use, ladies and gentlemen, just to think about this carefully. This thing right here, this 10.85, did you have to round this? Or did it come out as exactly 10.85 when you did your math?
You rounded.
We rounded a little bit, right? It was pretty close. It was like 10.850, blah, 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 blah. But you did round. So I would recommend not using that one as one of your pieces of the trig functions. Now, if you get stuck and you're like, I don't know what to do, then it's fine to use it. But I would recommend using the ones that you know much more certainly, which are these two here. This one over here, the 3.1, is the what of your triangle? Hypotenuse, adjacent, or opposite? Adjacent. And the 10.4 is opposite. So we think back, we look at our equation sheet, we look at our notes, we've got opposite and adjacent. Which trig function are we going to use? We are going to use tangent, absolutely. So the tangent of theta is equal to 10.4 kilometers divided by 3.1 kilometers. Remember, we got to do the opposite or the inverse of that in order to find our theta. So theta is going to be equal to tan inverse of 10.4 divided by 3.1. Tan inverse of 10.4 over 3.1. Is there anybody that's having issues or questions about how to plug that into your calculator? Can I help you with that? If you are not able to do it yourself, I want you to let me know. Or talk to your table mate. That's fine too. Yeah. What do we get for theta? What'd you get? 73.4, she says with certainty. Anybody want to corroborate that? Yeah, we agree? 73.4. So then we're almost there, right? Oh my gosh, it's like we're so close. We're going to get our pencils out. We're going to use them as pointing tools. We're going to place it in one of the directions that is a cardinal direction. So on my triangle, I'm going south, right? I'm going to start south. And then I'm going to turn which direction to find my resultant? Turn to the west. Are you a brave mathematician?
No, I'm just wondering because the green one was the first one, and I thought you put it on the first one.
Nope, you do not have to. So when you're finding the angle, that's a really good question. When you're finding the angle, you want to put your pen or pencil on the leg of the triangle that you're